Diving deep into scikit-learn Gaussian process kernels and their hyperparameters. Gaussian processes GPs are powerful tools for modeling and predicting complex relationships in data. In the scikit-learn library, the Gaussian process regressor and Gaussian process classifier classes implement GP models. The heart of these models lies in the kernel function, which defines the covariance between data points. The choice of kernel and its hyperparameters crucially influences the resulting model's performance and interpretability. Understanding kernels. Concept kernels are functions that measure the similarity between data points. They essentially tell you how likely 2 points are to be close in the latent space. Importance: the kernel defines the smoothness and shape of the learned function. A smooth kernel, e.g., RBF, will generate a smooth output function, while a rough kernel, e.g., Matern, can create more complex, potentially discontinuous outputs. Types: scikit-learn offers a variety of kernels, each with its own properties. RBF, radial basis function, the most common kernel. It's a universal approximator, meaning it can theoretically approximate any continuous function. Its hyperparameter is the length scale, which controls how quickly the similarity decays with distance. Matern, a generalization of the RBF kernel that offers more control over the smoothness of a learned function. The new parameter available in Matern kernels controls the level of smoothness. Higher values of new lead to smoother functions. Linear assumes a linear relationship between data points. It's a simple kernel suitable for problems where the underlying relationship is known to be linear. Polynomial allows for capturing nonlinear relationships. It has parameters for the degree of the polynomial and the coefficient. Constant, a simple kernel that assigns a constant value to all pairs of data points. It's useful for modeling data with a constant mean. White kernel models noise in the data. It adds a diagonal term to the covariance matrix, which accounts for uncorrelated noise. Rational quadratic offers a combination of RBF and linear behavior. It's useful when the exact length scale is unknown. Dot product computes the dot product between two data points. Suitable for data that lives in a high-dimensional space. Hyperparameter optimization. Importance: selecting the right kernel and tuning its hyperparameters is crucial for building an effective GP model. Tuning methods. Grid search evaluates the model performance for a predefined range of hyperparameter values. Random search randomly samples hyperparameter values from a specified distribution. Often more efficient than grid search, especially for high-dimensional hyperparameter spaces. Bayesian optimization uses a probabilistic model to guide the search for the optimal hyperparameters. This method can be more efficient than grid search or random search, especially when dealing with a large number of hyperparameters. Hyperparameters to tune. Length scale: RBF kernel controls the smoothness of the learned function. A small length scale results in a highly localized function, while a large length scale leads to a smoother function. New Matern kernel controls the smoothness of the learned function. Higher values of new lead to smoother functions. Degree polynomial kernel controls the degree of the polynomial used to model the relationship between data points. Coefficient polynomial kernel scales the polynomial terms. Constant kernel defines the constant value assigned to all pairs of data points. Noise level: white kernel controls the amount of noise in the data. Beyond the basics. Kernel combinations: you can combine kernels using the sum and product operations to create more complex models. This allows you to capture both global and local features of your data. Kernel engineering for specific applications. You can define custom kernels that better capture the relationships in your data. Interpretability GPs offer a natural way to quantify uncertainty in your predictions, making them suitable for tasks where understanding the confidence in your predictions is important. In summary, choosing the right kernel and optimizing its hyperparameters is crucial for successful Gaussian process modeling. Understanding the trade-offs between different kernels and their associated hyperparameters allows you to build flexible and powerful models that can effectively capture complex relationships in your data.